might have this.
Whatever. Hey, when are we gonna get home to New York? Daddy wants me there in about 2 hours.
We should be getting there soon. We're currently above Wisconsin.
Wisconsin. Hey, that's the milk capital of America. They have a lot of cows, right?
So I've heard, miss.
Okay. Well, when are we gonna get there?
Well, I'm not exactly sure, but your dad shouldn't be too worried.
Fine. Oh, cool, you have Arizona. I'm sorry. I'm
What
sorry.
the French
It's
toast,
because you
miss?
can put it on autopilot, right?
No, that's not how autopilot works.
Why not?
It doesn't.
Dad's not gonna like this. He's not gonna like this.
I know, but hold on. Let me call air traffic
Serious?
control. Emergency, air traffic control.
Mushrooms.
Please.
What the heck?
Answer us, please.
Dirty math? Got yourself in the dingies? Well then clean it up with a fresh set of calculus problems. A plane is falling out of the sky from a height of 20,000 meters directly above a children's playground. A person on the ground is aiming a missile at the plane about 1,000 meters away from the playground. How fast is the angle of elevation from the person to the plane changing at 1 minute after the plane starts falling?
So following the diagram, you can see that tangent theta equals d over 1,000 meters, or just 1,000. So when you take the derivative of tangent is secant squared, and we use chain rule for theta, so d theta dt equals 1 over 1,000 times dd dt. D equals total distance. Normally, we would put that as the initial height minus the falling height, but because acceleration is negative, it's just going to turn out to be negative. So we can put d initial, d naught, plus d falling. So d initial plus the physics equation, v initial t plus 1/2 at squared, where the initial velocity in the y direction is 0 meters per second because they're flying at a constant altitude. And then we follow down, so because v naught is 0, that's going to cancel out v naught t, and then you have d initial plus 1/2 at squared, and then the initial height is 20,000 meters, and acceleration is just acceleration of gravity, negative 9.8 meters per second. So we plug that in, and we have 2,000 plus 1/2 times negative 9.8 times t squared. Taking the derivative, we have just 20,000, which is a constant, so that just comes out to 0, and 1/2 times the squared here, so we bring that down to 2. 1/2 times 2, negative 9.8, because it's a coefficient, and just t to the first power, which comes out to negative 9.8t. So we can plug this back in, because it's d dt, back into this original equation here, and we have secant squared theta times d theta dt equals 1 over 1,000 times negative 9.8t.
So secant squared theta times d theta dt equals 1 over 1,000 times negative 9.8t, which equals negative 9.8t over 1,000. Now, d theta dt equals cosine to the second theta times negative 9.8t over 1,000. Now we must find d to find cosine squared theta. Now, d is 20,000 plus 1/2 times negative 9.8 t squared, in which t is 1 minute or 60 seconds, which would make d 2,360 meters. Now we must find cosine squared theta, but first we must find theta. Tangent theta is d over 1,000, which is 2,360 over 1,000, which means theta is 1.17 radians, which would make cosine theta 0.39 and cosine squared theta 0.15. So d theta dt is 0.15 times negative 9.8t over 1,000.
Now d of theta over d of t equals to 0.15 times negative 9.8t over 1,000, and t being the amount of time we're going to use. So now it leads to 0.15 times negative 9.8 times 60 over 1,000. So now we know the rate of change of that angle for that time is negative 0.0895 radians per second. Okay, so now our passengers should know what they should do. And it is up to us to take the proper action. Okay, missile configuration. Launch missile, yes. In 3, 2, 1.
I can't believe we survived that. Daddy's still gonna fire you.
Now I'm feeling so fly like a G6.